Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to Inscribed Angles. Now, if you've watched my previous videos, you might have seen a video about central angles. So I'm going to go ahead and make sure that I use the central angle to help us understand how to find the value of an inscribed angle. So first of all, we need to go over what an inscribed angle is and how it differs. So I'm going to actually just use the diameter in this case. So here's the diameter, and we'll call this K. So J and L. So angle, put a mark through that, JKL is inscribed as its vertex is on the edge of the circle. Okay, and I'm going to go ahead and say this is a 70-degree arc. So I want to know, how does this arc over here, arc JL, how does it compare to our inscribed angle size? And I wouldn't expect you to know that right off the bat, so here's what we're going to do. We're going to use what we do know. We know that we can connect A to J, and we will have an equilateral, or not an equilateral, an isosceles triangle. The other thing we know is that now this angle right here, because it goes to the center, is an inscribed angle. And since this is 70, this is 70. Okay, well, I happen to use a diameter here, so if this is 70, this is 110, right? Because they add up to 180. All right. So what's that leave for these two to share? Well, because this angle is congruent, this would have to be an x as well. So x plus 110 has to equal 180 degrees. So 2x has to equal 70 degrees. So x has to be 35 degrees. Okay. Would that always work? 70, 35. Actually, yes, it does. So what we know is that an inscribed angle equals half the arc length, or the arc angle. Remember, the central angle equals the arc angle. Plus, we can visually see that this angle right here compared to this angle right here, they just can't be the same. So we're still connecting to J and L in both of those, but K kind of. So that was using the diameter as one leg. What happens if, can we see the same thing otherwise? Well, let's draw another circle as soon as I find my compass. There we go. I have a circle drawn. Put my point in here for the middle. Okay. We'll call this X. this y, and this z. And this arc right here is going to be 100 degrees. Okay? So I want to figure out this angle. Now, you might already know it because you might have paid attention to what we just talked about. But the first thing I'm going to do is I'm just going to draw right here. Okay. Is that all right? Now we know that this is congruent to this, which is congruent to this, right? So we have two sides of the triangles that are congruent. We don't know anything else. So we'll go ahead and draw. We're going to extend this if we want. Okay, so now I'm going to do some trick labeling kind of thing. I'm going to call this D. So this would have to be D because it's an equilateral or isosceles triangle. I'm going to call this E and this E, right? Now from what we just talked about in our first one, if this is D, if we treat that as one angle, this is 2D. And if this is E, then this would be 2E. And we know that 2D plus 2E has to equal 100. So if we cut everything in two, D plus E has to equal 50. And isn't this angle, by angle addition postulate, going to be D plus E? And therefore we just showed that this is half to that. Okay? It doesn't matter where the corner is. Okay? It doesn't matter. If it's an inscribed angle, meaning the edge is on the side of the circle, so to the edge, if this in here is 15 degrees, this out here would be 30 degrees. That's that relationship. It's just a 50% relationship. So how can we use that to solve problems? So here we see an image. We have several variables on it. We have Q as the center, and we have R, S, T, U, V, and P as different points. So if I give you that arc RST is 164 degrees, what is the measure of angle RVT? Okay. So arc RST, I'm going to highlight that in orange. So I got to start at R, go through S, all the way to T. And if I were to connect that back, R to V to T, okay, that's that arc with that inscribed angle because the vertex is on the side. It's not a central angle, it's an inscribed angle. So that's that 50% relationship. So 164, if I cut that in half, I'm down to 82 degrees. Okay. So what if I gave you that the measure of angle SPU is 79 degrees. So S to P to U is 79 degrees. And I asked you to find the measure of STU. Okay? Starting at S, continuing to T, and on to U. Ah. Now remember, the arc is bigger than the angle. So it's that 50% relationship, but we have to go backwards. So we'd have to double that 79 and we find out it is 158 degrees. Also, it does look like it's more than halfway, right? I don't always draw them well, but in this case I did. So we can use those angles and we can start looking at, okay, if I have these different lines meeting, how much of this circle goes here, how much of it goes there, how does it split up, right? Okay, so now we're going to explore the relationship between a chord and a tangent line. And this is where you might lose you. You might go, what? There's too many here. It's all right. So get that circle on there. Okay, I have my circle. I'm going to call my center P. Just going to draw a couple of these. I'm going to draw a chord. Okay, so right now you can see that I've drawn two radii. I've drawn a point tangent. We're going to put this as point E. And we'll call this A. We'll put a random point here, B. And we've got P. So, how long is the measure of arc A, B, E? Well, P happens to be the center. And we know that when you have a central angle, the arc happens to be the same length as our central angle. So that's 80 degrees. Okay, great. Now, we also know that this is an isosceles triangle. So if you have two sides the same, you have two angles the same. So since this is 80 degrees, it leaves 100 degrees to share between our two corners, making this a 50-degree corner and this a 50-degree corner. However, I know that to get from PE to this tangent line, that's 90 degrees. So if this uses 50 degrees, then this angle right here would use 40 degrees. So the measure of angle, we need another letter, don't we? We'll call this D. AED is 40 degrees. So even though one side was outside the circle, because of all these relationships, this happened to still be half of the arc size. So when the vertex, okay, when the vertex is on the edge of the circle, the angle equals 1/2 the arc. So that's kind of a big deal. Again, our vertex is on the edge of the circle. So we can use that to our advantage whenever we want. So inscribed angle, vertex is on the edge. So let's just do one last example, and I think you're going to have it. So that's just a matter, you can draw all these triangles and you can actually use corresponding parts if congruent triangles are congruent and start looking at the angles themselves using just a central angle, or you can start learning about what does an inscribed angle do. All right, so we've got a circle coming back here. I don't even care how big they are. Okay, we need a center. Got a center P. We're going to pop in this. We'll call this point C. And then we're going to draw a tangent line through point C. B, D, A. And get another tangent line going over here. (115 degrees right there. We're going to call this F, this E, and this G. And the tangent lines are going to keep going. They're not just segments. Okay. Find the measure of arc FAC. I did forget to put one number on there. AC is 88 degrees. Okay, so let's find also the measure of angle ACB. Okay, well, right here, we can see that's 88. There's an angle that creates that arc. So 88, we're going down because the angle is smaller than the arc. So that makes this 44 degrees. Okay, and FAC. We're supposed to find the measure of arc. FAC. Well, there we go. So they gave us the angle, they want the arc, we got to get bigger. So 115 doubled is 230. So just understanding the relationship between a central angle, where they're going to match, or an inscribed angle, and that's where the arc is half. So if the edge is on the circle, it's 50%. If the vertex is in the middle, it's equal. So make sure you make some flashcards or something to tell you the difference if need be, and you'll be a rock star. You've got it.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.